Good morning. I think I've been set up this morning by Mr. Eggers. The expectations are horrendous here of what we have to do, but we can move forward, and we don't have to wait for 2 years of specifications to actually get some of this process working. So the idea is that we do things with the tools that we've got right now. The tools coming later will do things better, but we can't just sit and wait for the future tools. Let me get this thing out of the way. So my name's Tony Mallia. I'm an architect with Odyssey Consulting. We're a service contract to the acquisition side of the Air Force. I want to thank the Air Force for supporting and helping me make this presentation. I haven't made a presentation to OMG for a number of years, but I've been involved for about 20 years. Involved in model-driven architecture, some of the early days of the aspirations of what this could all do. I want to say to my own personal opinions, but it's based on the general problem that I think we're facing, and as a lot of organizations are facing in terms of the same. My big challenge this morning is to try and keep this within the time limit. This is a huge subject, so I'm really going to scope where some of the areas are. Nope. Neither of that worked.
The events laptop was muted accidentally, it looks like. Oh, now it's unmuted. Okay, thank you.
Okay, right now, so right.
It works now. It works now. Okay.
I'm sorry, there was a question?
No, I was just noting that the laptop had been muted temporarily, but now we can hear you again.
So looking at some of the drivers of this, the stakeholders that are involved in this are distributed in organizations. Models need to be oriented to stakeholders' concerns. And Mr. Eggers was talking about this. What stakeholders, and how do you present this to the stakeholders? They're usually close to the operation and strategic needs, or in their resource acquisitions or development and sustainment viewpoints. We haven't talked about model use throughout the life cycle, but that's typically what you need to look at. Here is a model of something, a release that is going in, it goes through development, goes to deployment, goes into sustainment, and then it goes into retirement. Retirement is actually pretty important because you're going to get all sorts of connections that have to be considered in the transition and the cutover in a sustained system to its next version. So we're looking at a wider scope here. The models represent shared intention and consensus of stakeholders. In other words, if you're on the same page, that page must exist. You can't claim you're on the same page and not have a page. And the model is probably the best representation that we have, even with its textual representation of the consensus process. The views need to be stakeholder-oriented, use stakeholder language. The way of focusing this is not to have UAF or SysML terms being forced into the presentation because nobody will really understand them. And that's the reality of particularly the users. The architects, the people who create it will, but the end users will not. Centralization of architecture does not scale. This is an issue that you've got to get the architects in close to the problem area. So if they're centralized, they're disconnected from the subject matter. So you've got to get them out there, and there are a number of three different ways you can handle the model. You could have one big model. You can have distinct, disconnected models, or you can have federated models. And I'm arguing that the single model is very difficult to manage. It's difficult to manage because change control is not really in there. You'd be talking about doing versioning by package inside the model. And so the process I'm going to talk about is the federation of model. And as I said earlier, we want to use existing standards and tooling, and we can use them with workarounds until such time that that becomes within the standard, and the standard gets incorporated into the tooling, and you're talking 2 or 3 years for that cycle to actually appear. The segmentation principles for the models, if you're going to use federated or distributed, is there are a number of axes that can be used. The first is the organizational capability. So here are a set of capabilities that are part of one of the organizations, and there's another set of capability of another organization, and they naturally belong in separate models because they're going to have separate architecture, separate subject matter experts. They're not going to be together. So a separation by organization capability. There's a separation by acquisition components. There's going to be a talk later on MOSA, which I'm great because I don't need to talk about that. But the idea of modular major components and resource project management. There's a specialization segmentation that may happen to say, this is an operational part of it, this is a digital part, this is electrical or physical parts of the model. And we're talking about everything that SysML can do and UAF can define, because we're talking about resources that include aircraft. And so that may be a segmentation. And then finally, classification, that came up earlier. We'll talk about it a little bit later. The security domains, and we've actually got to federate our models if they're going to fit in the multiple classifications. The convergence is really important. We really want only a single representation of a concept. If we've got two representations of a concept, we've got two sources of truth. So what we want to get is sort of third normal form of models. And this may not be totally possible, that you will see that there's the same concepts being modeled twice, and we need to be able to deal with it. The convergence is across a number of different things. We talked about shared platforms and networking. I'm not sure that we're going to get to a single platform. I think that the reality of it is we're going to have distributed platforms, and that we need exchanges between those platforms at the classification level to basically say we can move this part or this model segment across a network and have it reused in a different environment. There's a terminology convergence. I'm not going to get into that, but this is the standard naming issues of identification. What's an aircraft type? There's a data domain model which is used for defining exchanges and persistence, so that we want to be able to reference those same concepts. I'm looking very excited about the data models in SysML2, which look like some very interesting pieces, and hopefully that whole piece will work into UAF too, so that we have some foundation of data types that can actually be reused from the standard. There's a security infrastructure and functions needs to be across groups, and the lifecycle states and milestones, because we're talking about developing systems. Architecture is not the end product. The end product is developing and deploying systems and making them work. So life cycle states and milestones. And if we look at the use cases, we think we can map the use cases that I actually saw for the first time from Aurelius, that we can map those into the stages of the life cycle. So what are you doing? What do you need to know in planning when you're 5 years out of deployment? What do you need for testing? What do you need for deployment? What do you need for troubleshooting and support? All these sorts of activities in the life cycle should be driving the use cases. And the cross-segment views, we need to do a number of things. The purpose of modeling, we've got to understand what the purpose is. And obviously, some of it is to look at the quality of what is being proposed to work. But actually, a lot of the purpose of the modeling is to check completeness. So for example, in the acquisition, do you have all the requirements being resolved? And are they all traceable? Or do you have some orphaned requirements? In other words, completeness is a really important concept, because completeness failure can actually be disastrous. So if you've left out a component in the architecture that's needed to be developed, and it didn't have its funding and it didn't have its program in place to actually put it in place in time for deployment, you get a serious discovery later on, coming up to testing usually. Come up to testing and find that that group didn't know that they were involved in the project, this worst case scenario, and that they didn't have the funding for it, and they didn't have the test environment that they were going to be able to participate. And capability deployment, readiness, synchrony. In other words, that these things coming from different organizations are going to arrive at the same time. So you can actually deploy it. And so synchrony between the capability releases, for example, is a really important thing. And that's part of the strategic view and the roadmap that's quite well defined in UAF. And I think we'll be able to enhance that considerably when we understand what phases really mean and how they should be used. And then the change impact projection is another reason why we want models. So we get to a technology refresh time, and a vendor has said, oh, we're not supporting that release of that product anymore. What impact? So it goes all the way down. I'm not saying it goes to configuration management, but that is actually a question on the table as to whether we might not be looking at an extension into configuration management to say, these are the assets and this is where they're deployed. So an approach to federated UAF, which I'm strawmanning because I'm trying to find whether there are other people that have worked this issue. So far, I haven't found a lot. I think a lot of concern and a lot of identification of the problem, but not a lot of cooperation yet in the working of it. We need a high-level federated set of models. The models can contain or they can reference other detailed models. So as you go down for the stakeholders, you can go down to a resource, and you can map to the models specific to do with that resource. There's a pattern that I've looked at, which is kind of old. It's the proxy facade pattern. I don't know if anybody remembers that, but it was one of the great patterns of that time. Look at federating the models using a producer and consumer of an exchange metaphor to say, here's a model that's describing a producer, here's a model that's describing a consumer. There's a relationship between them. Now, a consumer can be a producer to another consumer. And so you basically network the models together, looking at the kind of the value stream of how things are getting done. And if you put them into these categories, You can then limit the views that people need by doing a black box, white box approach to both the producer and consumer. And the black box is the facade. And that basically says this is how you access the producer's information. And it's purely the external position. The internals are hidden, but this is the stuff you need to know to work and collaborate with the producer. And there's a core, and I don't find the right name for this yet, but it's kind of the inner model that uses the facade. And there's a proxy that's produced by the producer, which is then given to the consumer. And that's the example of how you use the facade. And you can actually implement the proxy, and there are some patents doing that one, but you can actually isolate the consumer from the transport mechanism by actually implementing a proxy that presents the interface up at an API level. And the two models could have exchanges in both directions. You could actually have, there's no limit on this, basically. Here's an example. We're actually doing all the concepts. We're testing out, and this is done in Cameo, but this is the model view of the model which uses the facade model, which uses the infrastructure model, which uses data model, common model. Notice that your model and another model are not actually coupled. So you've got them loosely coupled here through the facade. And that means that the producer can version control the facade and change the stuff internally. And as long as the facade doesn't change, it doesn't ripple through the proxy, ripple through to the consumer. And implications of this is that we need a style implementation guide. And I don't mean a style that represents a style for your construction of the model in the containment section more than anything else. We need a subset of UAF elements and relationships that we're going to be able to handle, because the scope of this with regard to the training and the education is overwhelming. And looking at a 400-page document or 500 or over 1,000-page document is not going to help us in the education. So we need use a subset of the elements and the relationships, and we need fit-for-purpose views for the lifecycle activities. They're often not the little pieces that are in the jigsaw puzzle. You're just seeing a piece of the jigsaw puzzle one at a time. They're much more likely to be the vertical sliver of this that says, at the executive level, they want to see what the reasons are for it, what it does, and who are the organizations involved in. Should be something in the budgeting exercise to cover that resource that's going to be built. We need to monitor. This note to me, monitor the UAF for acquisition, and I'll be listening to the other presentation today. So the whole area of a government resource architecture being supplied to a vendor, the vendor coming back with a model. This is federated model. And we want to be able to cover all that because vendors are stakeholder. So one of the things implications is we need to pay attention to namespaces and qualified names. Drilling down a little bit into the geeky stuff here, but we need to make sure we don't get collisions in naming, and there are going to be some rules for doing that avoid that and happen with kernel and SysML2, and kernel has the namespace declarations. So we need to be looking at kernel right now, make sure it's optimized. We cannot wait enough. There's a way to do this, and it's to do with the package instruction in the model. And there's some notes here really for me, is that the UF package naming sometimes from the tooling gets in the way because it gets inserted into the qualified name. The usage across models without an import needs to be defined. I believe that this is a vendor feature. The standard says import, but import changes the imported model, so it's actually no longer readable. And that's a very important thing, is when you use somebody else's model, it's read-only. And if it changes, the author needs to change and give you a new version, and you need to do with that version. So the moment that you've got somebody copies a model across and then changes it, you've got a branch. And you've got a branch that doesn't have any governance and control. So the part of the approach to this is to say, no, you share models and they're read-only. And it has to be a negotiation for the change. It has to come back between those modelers. And so it's read-only control. And we've actually got this working in Cameo with a small test model, and also with some larger stuff that I'm not going to go into. One of the things about UAF, in looking at the guide, and I assume that most people have looked at the guide, the EA guide for UAF from OMG, very interesting. But in a federated model area, you do not want each program going through step 0. Because that's basically going to set up the framework for them. So you want a shared step 0 at some point in the enterprise. And I don't know how high that is. We want to get it as high as possible, saying, this is the way that you is already or mostly done. And there could be some pieces in step 0 that haven't been done. So we need a shared step 0. And you can see the implications. We need a total exchange flow. So this is the upper level, because it's going to allocate as part of the governance as to who has the decision rights on the parts of the model that are going to contribute to the overall arching flow. We need to identify the common shared models, which are a little bit more difficult. So infrastructure that's part of a specific project, not common, may go into the project's part of the project's model cluster and not be in a common. But the more you've got common infrastructure, the more you can actually refer to the common infrastructure model. And responsible modelers with a common style guide and example. And now we're starting to talk about governance. And so part of this challenge is where does that sit? Who's going to rule that? So before we do that, I thought it would be interesting to look at the search and rescue model. I'm sure quite a few of you looked at the example. Hopefully a new one coming out. I don't know whether there's plans to do a new search, but I thought, how would the search and rescue look like with a real Coast Guard? And the rescue organization search is basically the British voluntary lifeboat mechanism, I think, more than anything else. But we've got two organizations here in combating networks, safeguarding commerce, and securing borders. And then under safeguarding commerce, they have search and rescue. used by the other organization. But it's not a self-contained model. This search and rescue is going to use resources that are across a whole lot of other capabilities. And I'm not going to try and model the US Coast Guard. You can see that these things don't exist in isolation, and they must be considered. So kind of in finalizing this, what are we dealing with here with the vision of UAF SysML as it goes forward? And I looked at a number of stakeholders to look at who might they be and what are we talking about. The first one was strategic capability planners, and Mr. Eggers had defined that very nicely this morning, saying this is what the vision is going forward. We've got requirements in acquisition. The vision's already established now. Now we're going out to contract for services. So there's requirements and specifications in both directions. We need the actual development and replication. Replication, I mean manufacturing, but anything that's then. So we've got the use of the model in that sense. And I want to just mention in resource development, model-driven development is right on our doorstep. It's right on our doorstep, and it's called low code. And the low code market is basically using models to generate code. So if you look at a number of these organizations, they have either informal or formal models that you can actually build, and then you can either generate the code or you can execute the model as an operational result. And I won't go into the vendors. I've been tracking this for 20 years. The first one that came out in about 2004 came out of Spain, and it was a tool, and it had a modeling language, UML plus some stuff. And you could say, do you want Java or do you want .NET? The button, you send the model to the service. 10 minutes later, it comes back with installable code. And we tracked that. I was working for a software services company, and we said, what's this going to do? What's the productivity? Gartner got hold of this. They said the productivity is 23 times what it normally takes to develop software. So even at 20 times, you're talking about a 95% reduction, 95% reduction in cost. Now that can go into a timing reduction, or it could go into a labor reduction. But watch low code, because I think there's an intersection here with the direction we're going. Testers, I don't want to get into the testing area, but one of the use of the proxy is your test harness. Your test harness is going to actually exercise the provider. Operational documentation and training. We haven't looked at document generation yet, but AIs are going to do that for us. Yeah, AI is going to do that for us. Deployment configuration management, I talked about that. Infrastructure support, what are we looking at? Operational management and issue resolution. The existence of models to be able to look at problem resolution. And finally, and not least, security.